Hello, everyone, and welcome back. I am Mr. Cobalt, and today we are going to be going over the structure of the atom. And so, uh, the first thing I want to talk about is this idea that the matter is all neutral, not atoms. Atoms can be of different charges, but matter itself is neutral. And the reason for that, and maybe a larger reason for that, is because atoms tend to have equal numbers of protons and electrons. So let me jump into the structure of the atom. So the way the atom is structured, as we know today, is electrons are on the outside of the atom. And then you have this middle part called the nucleus. This is not a perfect representation of what the modern theory of the atom is, but it's good enough for an explanation of what we know today. So electrons are on the outside, and you have protons and neutrons on the inside. So there are three basic subatomic particles that make up the atom. They're the electrons, and the electrons are on the outside, and the electrons have a -1 charge. Now, that's not really the charge on the electron, but it is a standardized charge, and so we associate a -1 with the electron. Um, Protons are one of the subatomic particles that are in the middle of the nucleus, and they have a +1 charge. So electrons and protons are oppositely charged. And we have neutrons in the nucleus as well. And so neutrons, as the name neutron implies, they are neutral, which means zero charge. So we have electrons, protons, and neutrons. If you have equal number of protons and electrons, then you have a zero charge atom. You have a neutral atom. Okay. So that is the reason, one of the reasons that the atom is neutral is because you have a balance of charge between your electrons and protons. You don't always have that balance of charge. There are atoms called ions, charged atoms, and ions do not have that balanced charge. But matter seeks to be neutral, right? So when you have an ionic compound, even though the atoms are charged, the compound as a whole is going to be uncharged because nature seeks to have that balance of charge. Let me give you a couple of examples. When you're walking across a carpet, you pick up charge, right? So you get that unbalance of charge as you are walking across the carpet. And to rebalance that charge, what happens? You grab something metal, you grab a doorknob, whatever it is, and you get a shock. You get a little arc of electricity moving from you to the doorknob or whatever object you come into contact with. Usually it's a metal, or it could be something else. But that shock or that arc of electricity that goes between you and the object, that rebalances the charge. Another example is lightning. So the balance of charge between the Earth and the atmosphere, lightning is that rebalancing of the charge. So nature seeks to be balanced in charge. It seeks that neutrality. Okay, so matter is neutral. Electrons are about 2,000 times smaller than a proton. And if you were to use an analogy or to try to give perspective on that, if the neutron or the proton were a baseball, the size of the baseball, then your electron would be the size of a grain of rice. So that's about as different in size as the electron is to the proton. And the protons and neutrons are the same in size, approximately very close to the same in size. Okay, so what I drew on the board is a representation or a model of an atom. In particular, this is the carbon atom. How do I know it's the carbon atom? Is because it has 6 protons. So the number of protons is going to determine what element you have. It identifies the element. So if you know the number of protons, then you should be able, you identify what the element is. So if we draw the symbol for carbon, usually you have the symbol C for carbon here on your periodic table. So if this was like a square, right? If I draw a square like that, so on the periodic table you'd have above the symbol, which is C for carbon, you would have a 6, and that 6 is called the atomic number, and the atomic number tells you the number of protons in that element or in an atom of that element. And the number of protons is what identifies the element. So if you know the number of protons, or if you know the atomic number, then you know the number of protons, and then you should be able to identify the element as carbon if it has 6 protons or has an atomic number of 6. And this is what you're going to see on the periodic table. So usually you have a square, and then the symbol is in the middle. The top number, which is usually large, is going to be the atomic number. And then below, you either have the name, the full name of the element written out, or you have the average atomic mass underneath the symbol. Okay? And so the chemical symbols that you'll find for various elements are written here as examples. And the symbol of the element is given here for these examples. Now, a lot of times the symbol for the element is just a single letter, and a lot of times it's the first letter of the name of the element. So C for carbon was a capital C. Fluorine, you have a capital F. Nitrogen, capital N. Okay, but also there's a lot of element symbols that have 2 letters. And you don't have more than 2. You either have 1 letter and that letter is capitalized, or you have 2 letters. The first one is always capitalized. The second one is always a lowercase letter, not both capital. Okay, so for example, you have iron, which is capital F-E. You have gold, which is capital A-U, and you have silver, which is capital A-G. You might have others, for example, cobalt, which is capital C-O, magnesium is capital M-G, and so on. And one thing you'll notice is that sometimes the second letter is the second letter in the name. So here's capital C-O, but not always. Sometimes it's the second letter after the first one. So the third letter is the first and the third. So for example, in magnesium, you have capital M and G, not M-A. Okay, so there are historical reasons for that. We're not going to get into it. The other thing I want to point out is, as you may have noticed here, the symbols don't quite make sense with the name. Why are we naming iron with a symbol Fe? Or why is gold Au instead of Go, or just capital G, right? That's for historical reasons. Many of the elements on the periodic table are named by either in Latin or Greek, right? So iron comes from the Latin for ferrous, which is the Latin for iron. Gold comes from the Latin aurum, and silver comes from argentium. So that would explain why those symbols go with these names, right? So a lot of them are based on Greek and Latin. Some elements are named in according to where they were discovered. Some are named according to giving respect or acknowledgement to the discoverer, or maybe even a particular famous scientist to give him props or something along those lines. So you'll see that on the periodic table. I hope this was helpful and insightful. So thanks for joining me, and if you like this channel, please subscribe, make a comment in the comment section below, share this video, like the video, hit the notification bell so you get notifications for more videos, and I'll see you guys next time. Thanks for joining me.